Hello everyone, my name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, and sometimes about software engineering in general. If you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you can follow me on Twitter as well. In this particular video, we are going to look into uh, how a particular Kubernetes object or a Kubernetes resource is represented in your Go source code. So if we very briefly try to define how a Kubernetes object looks like in your Go code, or what does it mean to have a Kubernetes object in your Go code. So any Go struct, if that struct implements runtime.Object interface from API machinery package, in that case it simply means that that particular struct is a Kubernetes object, or can be considered or can be called as Kubernetes object. Let me try to repeat that once again. So we can say that if any Go struct implements runtime.Object interface from API machinery package, in that case we can say that that particular Go struct is a Kubernetes object. Now let's just go ahead and try to have a look into this particular interface and what are all the methods that this interface exposes. So let me Okay, so now I'm using Visual Studio Code to navigate through the code base, but you can obviously just search for runtime.object from API machinery package on Go doc as well. So as we can see here, this particular object has two methods, get object kind and deep copy object, and get object kind returns another interface that has two methods, set group version kind and group version kind. So we basically are dealing with three methods here. Two are set group version kind, group version kind, and one is deep copy object. So if we go ahead and try to have a look into what we have already discussed, if a particular Go struct implements set group version kind, group version kind, and deep copy object, it simply means that that particular Go struct can be called as or can be considered as a Kubernetes object. Now if we talk about these methods, as this particular name suggests, using set group version kind, we can set group version kind for a particular Kubernetes object, and using group version kind we can get group version kind of a particular Kubernetes object. If you are not very sure about what group version and kind means, I have created some videos about that, so maybe you would want to check them out. Now that we know about these two methods, let's talk about deep copy object. So deep copy object is a method that can be used against any Kubernetes object to create a deep copy, or let's say to create a copy of that particular object. And why do we want to do that? We are going to discuss about that in a bit, or in later videos. So if I try to summarize it once again, any Go struct can be called as Kubernetes object if that Go struct implements these three methods, or in other words, if that Kubernetes struct is able to set group version kind, get group version kind, and deep copy object. So yeah, this is what it means when we say a Go struct to be a Kubernetes object. Now we are going to have a look into a particular resource, and we are also going to look into how that particular resource implements these three methods. So if we have a look into this code that we wrote in the last video, so we know that list returns pod list, and we are just going to look into the pod struct. Okay, so this is how the Kubernetes object in Go code looks like. Now, as we have discussed, this pod can only be, or this struct can only be considered as a Kubernetes object if it implements those three methods. So now we are going to look into how this pod implements, or how this struct implements those three methods. So those three methods are implemented two of those methods are implemented by help of this struct over here, that is inline embed in the pod struct. And if we look into this type meta struct here, it has two fields, kind and API version. And this particular type meta struct implements two methods that we have already looked into, that is set group version kind and group version kind. So if we try to figure out all the hold on, something is wrong with my okay. So if we try to figure out all the implementation of set group version kind, and if we look into this particular source file, so if you see these two methods, that are set group version kind and group version kind, are implemented by type meta struct that we were just looking into. So if we click into type meta, this is the object that we have been looking into, right? And if we click into type meta, this is where it goes. So in other words, what we can say is pod struct implements two methods, that are set group version kind and group version kind, using type meta struct that is already embedded in the pod struct. Now if we talk about deep copy object, that deep copy object is also implemented by pod struct. If you want to have a look into that, we can also look into that as well. So we just have to go to implementations. Okay, so now we have all the implementations. We have to look into the file that is in core v1, because we know that pod is from core v1. So just a second, let me find that out. So here we go. We should be able to see deep copy object being implemented by pod resource, as you see here, and this is the pod type that we are talking about, right? So if we try to summarize everything once again, if we talk about pod type, pod implements this runtime.Object interface with the help of type meta, and it directly implements deep copy object. So pod directly implements deep copy object. So in other words, we can say that pod implements runtime.Object, and that is the reason pod struct can be called as a Kubernetes object. Now we would be able to see type meta struct being used in almost every Kubernetes object at very top level. So for example, if we talk about any Kubernetes object, at the very top level we would have type meta, and obviously type meta is going to have the details about the type that we just looked into, kind and API version, and then we would have other details, for example set spec and other things that we are going to look into in a bit. So I hope type meta makes sense. So type meta is a struct, we can say, that is used in almost every Kubernetes object to implement those two methods that we looked into, that are set group version kind and group version kind. So yeah, now that we know about type meta, we can use type meta to specify type of a particular resource. So for example, when we specify a particular Kubernetes object, this is what we do, right? API version and then kind. So this is what type meta actually means. So API version, for example, we specify apps v1 and kind, let's say deployment, and this is what is mapped to type meta in Go code. And if we go ahead and try to have a look into type meta, as we can see here, kind is to be represented as kind, and API version is to be represented as API version. And that is the reason in Kubernetes manifests we see these fields as kind and API version. So I hope that makes sense. Now what we want to have a look into is object meta. So now that we know why do we use type meta, now let's go ahead and try to have a look into object meta. So type meta is used to define or specify type of the object. Object meta is used to specify other metadata details about that particular Kubernetes object. For example, name, namespace, labels, annotations, resource version, etc. Resource version is very important, I would say, and we are going to have a look into that in just a bit. So now that we know a Kubernetes object is represented or consists of type meta, object meta, after that comes spec and status. So spec is the thing that we as users of Kubernetes specify as expected state. For example, let's say when we specify a deployment or when we define a deployment, we say that we want 3 replicas of a particular pod to be running. So that is expected state. And so that is how we define, that is the significance of spec. And if we talk about status is the field that a controller updates for this particular object. Now if you are not aware about controllers, I have a video about that, maybe you can check that out. But if I quickly explain that, for example, there are some things that need to be updated by a program that is running on Kubernetes cluster. For example, let's say if you want to perform some activities using this particular resource, and once that activity is done, you can update the status to be, let's say, true or done or whatever you want to, right? So this is the significance of all these things that we can see here in the Kubernetes struct. So we know why do we use type meta, we know what is object meta, pod spec, and pod status. So now if we go ahead and have a look into this code base that we have written already, I would like to talk about the client sets that we get when we call new for config for Kubernetes object. So if we click on new for config, we can see that it gets us client set, and we call it client set because of a particular reason. And the reason is it gets us clients of all the group and API versions. When I say all there are some exceptions. For example, it doesn't get us the client set of custom resource definitions and API services. So custom resource definitions are also Kubernetes objects and API services as well. So it doesn't get us the client set for those two resources, I would say. But apart from those, it gets us client set or clients of all the group versions that are registered on the Kubernetes cluster, and that is the reason we call it client set. So if we look into client set, and for example, let's take an example of apps v1 group, right? Apps is a group, v1 is version, apps, it returns apps v1 client, and apps v1 client implements all these methods, let's say. So for example, these are all the methods that are implemented by apps v1 client. And let's go ahead and have a look into, for example, deployments. And it returns deployment interface. So when we call deployments, it returns deployment interface, and deployment interface has all these methods that we can call to obviously perform these operations for or on deployment resource. For example, we can call create, update status, and things like that. So if we go back to our example once again, so if you see here, this deployment gets us that deployment interface, and deployment interface returns, as we just saw, it returns, sorry, it specifies or exposes these many methods. That is the reason we are able to call these methods on deployment interface that gets returned. So as we can see, all these methods are self-explanatory. I would say create, update, delete, update status is used to update the status that we looked into. Get, list, watch is a special kind of method, I would say, that is used to watch a particular set of resources. So for example, if you remember, a lot of times what we do is kubectl get pods -w. It simply means that the list would be updated in a specified in a certain interval. So that is how watch method is how that particular thing is implemented. So, or in other words, we can say that using watch method, we can watch for changes on a particular resource. So we can see here, watch method returns an interface, and this has a channel of events, and this channel gets all the events. For example, if the resource is added, modified, deleted, etc, etc. So yeah, I think this is what I wanted to talk about the methods that are implemented by a particular interface. Now, for example, if you want to listen for the events or modifications on a particular resource, you would want to use watch, but we don't use watch method because of a lot of reasons. For example, let's say if you use watch to listen or to monitor modifications on a particular resource, you would be making call to API server again and again. So that would be very heavy on API services, Kubernetes API services part, and there might be some failures. So you would be handling them manually and things like that. So that is the reason we don't use watch. Instead, we use informers that we are going to look into in later videos maybe. So apart from that, what I wanted to discuss about is the config that we get by default, and this particular config is used to get the client set. And we can also specify custom configuration, and that is what I would like to explain next. So it returns rest client.config, and if you look into this particular struct, it has a lot of things, and some of the things that I would like to talk about are QPS, burst, and timeout. So QPS stands for query per second, I think, and if you read the comments, it indicates the maximum QPS to the master from this client. So obviously we are creating client to talk to Kubernetes API server. So this specifies maximum queries per second, and by default it's 5, and we can increase that as well. Same goes with burst. The default value is 10. And if we talk about timeout, so when we use when we run, for example, let's say when we run dot list, this particular call to Kubernetes API server doesn't have any timeout set. So client doesn't have any timeout set. By default, Kubernetes API server is going to try to respond to this particular request within 60 seconds, I think. And if API server is not able to entertain that, API server is going to time out, but we don't have any timeout at the client level. So all these things that we just looked into can be configured by the client itself. So for example, let's say I want to set custom timeout from client side. What I can do is config dot timeout, and let's say 120 into time dot second, and now we have custom timeout at the client level, right? If we don't set this timeout, the default timeout would be a value of 0 means no timeout, and in that case API server is going to timeout if the request is not long running request. If we talk about long running request, there are some long running requests. For example, if we port forward to a particular pod, that request also goes to Kubernetes API server, but that request is long running request. But if you want to list a particular pod, that request cannot be considered as long running request. So yeah, this is what I wanted to talk about. I was not able to code this because I think explaining that would make sense. Maybe in the next video we would actually try to look into informers and write some code so that it would make more sense. If you liked the video, you can again subscribe to the channel, share it with your friends, and yeah, thank you for watching. I'll see you in the next one. Thank you.